In this video, we're going to look at solving equations with rational coefficients, or with fractions and decimals. So the big idea here says we want to remove all the fractions and decimals from the problem. To do this, we multiply each term by the least common denominator. I call it the LCD. Think about least common multiple. We're just talking about denominators. When dealing with decimals, we will multiply all terms by a multiple of 10. So we'll look at some decimal examples in just a minute. First two we're going to look at are fractions. All right, so notice here in example 1, we have 4x minus 18 equals 14 over 4x. So in this case, it's an easy example. There's only one denominator. So that's what I'm going to multiply both sides by. So I like to start off by saying prepare both sides of the equation with parentheses, right? Prepare with parentheses, kind of makes sense. So now I'm going to write a 4 out here. That means I'm multiplying by 4. So here I do the distributive property. 4 times 4x gives me 16x. And then I do 4 times negative 18. So I do 4 times 18, we get 72. That's going to be negative 72, or minus 72 equals. Now here, these numbers right here are going to cancel each other out, right? Because if I divide a number by 4 and then multiply by 4, those just cancel out. So I'm left with 14x. Now I solve my equation. Subtract 16x from both sides. So I get negative 72. 14x minus 16x is going to give me a negative 2x. And then I would divide both sides by negative 2. So I get x equals 36. Simple enough. Example number 2. Now we have two fractions, but they both have the same denominator. So once again, prepare with parentheses. And we don't have to guess we don't have to figure out what to multiply by because there's only one denominator. So we're going to multiply both sides by 7. These 7s cancel, so we just get x plus 7 times 6 is 42. Distribute here. Once again, the 7s will cancel, so we get equals 3x minus 7 times 4, 28. Now we combine like terms. Add 28 to both sides. So we get x plus 70 equals 3x. Subtract x. Remember, that's like 1x. 70 equals 3x minus 1x is 2x. Divide both sides by 2. And we get x equals 70 divided by 2, which is 35. All right, let's look at some more challenging examples. Okay, now example number 3, we have 3 fractions, and all 3 fractions have different denominators. Okay, so we're going to think about, all right, what are our common multiples of these numbers? Well, multiples, remember, are numbers that, it's kind of like skip counting. So multiples of 4, 4, 8, 12, 16, 8, 16, and then also 16. So we're going to prepare with parentheses, and our least common denominator will be 16. Okay, that's going to help us get rid of all the fractions. So now we're going to multiply here, multiply both sides. So now we're doing the distributive property. So we have 16 times x, which would just be 16x plus. All right, now here we have a couple options on how we want to think about this. We could do 16 times 6 and divide by 8, or 16 divided by 8 multiplied by 6. I like to do it that way. It makes my numbers smaller. 16 divided by 8 is 2. 2 times 6 is 12. Now let's do it this way. 16 divided by 4 is 4. Times 2x would give me 8x. And then here, these 16s will cancel. So that's minus 4. All right, so now we just solve. Once we get to this point, all of our fractions should be gone, and we can just solve like a normal 2-step equation. All right, so now we have 16x plus 16 equals 8x. Subtract 16x from both sides, and we get 16 equals negative 8x. Divide both sides by negative 8, and we get x equals negative 2. All right, example 4, we have some decimals. Okay, so we said we're going to multiply each term by a power of 10. Another way to think about it is we're going to move each decimal the most number of times so that all of our numbers are whole numbers. So here's what I mean by that. How many times would I have to move this decimal for that to say 10? 1, 2. 24, 1, 2. So this one, I would only have to move it once to make it say 9, but since I had to move these twice, I have to move this one twice as well. Same goes here. So 1, 2, so now that's 10x. 1, 2, minus 24. 1, 2, don't lose the x. So now that is 90x. 1, 2, plus 56. Now we solve. Add 24 to both sides. Those cancel, so we get 10x equals 90x plus 80. Subtract 90x from both sides, and we get 10x minus 90x would be negative 80x equals 80. Divide both sides by negative 80, and x equals negative 1. Last two examples. Increasing difficulty here. We're going to start off by distributing a fraction. Then we're going to have to multiply. Then we're going to have to multiply by our least common denominator. So I move this here to distribute. Same thing here. 4 over 6 times 2x, right? So 4 times 2 gives me 8, okay? And so I'm going to have 8 over 6x for right now, okay? We'll get rid of that denominator in a minute. Now we're just multiplying fractions like normal. 4 times 2 is 8. 6 times 4 is 24. Okay, we could reduce these fractions, but we're going to get rid of them in just a minute. Okay, distribute here. 2 over 8 times 6 over 1 is how we could look at it. So we get 12 over 8x minus, now we do 2 times, we already put our minus here, so 2 times 14, we get 28, and that is over 8. Okay, now we look at our denominators. 6, 24, 8, and 8. So our least common denominator of these four numbers is going to be 24. So we're going to prepare with parentheses and multiply all the terms by 24. Okay, so multiply here, multiply there, multiply there, multiply there. So think about it this way. 24 divided by 6, 4 times 8, 32. So we have 32x plus, look at these 24s, they cancel. So that one's easy, 8. Okay, 24 divided by 8 would be 3. Times 12 gives me 36x. 24 divided by 8, 3. 3 times 28 gives me 84. Now I solve. I can add 84 to both sides. So I get 32x plus 92 equals 36x. Subtract 32x from both sides, and we get 92 equals 4x. Here we would divide both sides by 4, so our final answer, we get 92 divided by 4, and we would say x equals 23. All right, last example. Looks a little bit different, but we're still going to follow the same principles. Prepare with parentheses, because we're going to be multiplying to get rid of the denominators. Okay, let's think about 3 and 5. Multiples of 3, 3, 6, 9, 12, 15. Multiples of 5, 5, 10, 15. So the least common denominator is going to be 15. Okay, so let's think about it the same way. 15 divided by 3 is 5. 5 times x minus 3, I could write as 5 with x minus 3 in parentheses. Now over here, 15 divided by 5 is 3 times x plus 5 in parentheses. Now I distribute. 5 times x is 5x. Minus 5 times 3 is 15. 3 times x is 3x. Plus 3 times 5 is 15.
Aiden Turney, please report to the nurse's office.
All right, now I'm going to add 15 to both sides. Those 15s cancel. So I get 5x equals 3x plus 30. Subtract 3x from both sides. Those 3x's cancel. So I get 2x equals 30. I'll bring that over here. 2x equals 30. Divide both sides by 2. So we get x equals 15. So remember, with our rational coefficients, the big idea, we want to remove all the fractions and decimals. It is possible to find out what the variable is equal to without getting rid of the fractions and decimals. It just makes it sloppy, makes it hard. Okay, so we're trying to make it as easy as possible for us. So to do that, we want to multiply each term by the least common denominator. And with decimals, we'll multiply all terms by a multiple of 10. Or we have to move the decimal the same number of times in each term.